So again, what's happening here is we have our standard grid system. We're going to draw some random angle theta in standard position, okay? And then on the terminal side is going to be some point xy. Now, I could choose to put theta anywhere I wanted, but for the interests of this course and to make this simple, I'm going to put it here in the first quadrant. So it's going to go to this real quick. How could I put a point on this graph, an xy point, where you couldn't even draw a triangle? Where could I put a point where there would never even be a triangle anyway? On the line, on the axis. So for example, if they say you have a point 0, 2, that has trig functions. We can find the trig functions for it. You don't have to write this down, just pay attention. I can't make a triangle out of it though, because the radius and the y are the same thing. So you couldn't do the whole opposite adjacent thing anyway. It wouldn't work. You can't make a triangle out of this because here's my y and here's my r. They're the same thing. It doesn't work, which is why I've abandoned teaching it that way at all. Okay, because I really think like this. So this is what is being described up here. All right, I've got this angle of rotation from this, the initial side ending at the terminal side, and that angle is theta. On the terminal side is some point xy. And for starters, what we're going to do is we're going to create a right triangle out of this picture. Right? So we don't have that yet. And then I'm going to show you what we're going to start moving toward. Let's create the right triangle. So for starters, I'm going to drop a vertical line down here. Okay, what is the length of this vertical line going to be? I'm sorry? I just didn't hear what you said. Y. Y. The height is going to be y. Okay? That height of this triangle is going to be y because this point represents xy. And so, of course, we talk about vertical distance. That's what the y does for us. All right. So then what is this distance here? X. Okay? So we're just forming that right triangle. Now, here's where things are going to be a little different for us. The hypotenuse of this triangle is not going to be labeled hypotenuse. Okay? Just the same way that these sides were labeled x and y. This is going to be called, okay, our hypotenuse is going to be called r. And it's called r because it really acts like a radius. Think about what you've been doing over the last couple days. This has always been anchored at the origin and we rotate it around. And so we get to the edge of wherever we are and it sort of serves as a radius. Now, the thing that's nice about this is everything that we already know about trig, everything that we already know about right triangles is true. Okay? So for example, if I were to look at this angle right here, we've already discussed that this radius is r is the same as the hypotenuse. Well, what is y the same as when we think about trig? It's the opposite from theta. Okay, so this is the opposite side. Well, what is x? The adjacent side. So in terms of trig, what we're doing is we're making a shift. For right now, we're going to keep the opposite hypotenuse, opposite adjacent in play. But it's about to shift away from that. Okay? So if I was to write the sine of theta for this situation, what would that be? What is the opposite side here? Y. What is the hypotenuse? Okay, so our sine of theta is y over r. So if I'm going that direction, how about the cosine of theta? Where do we go ahead and write the cosine of theta out? In that way, and then also do the tangent. Cosine. X over r. Tangent. Y over x, okay? Now, here's the thing. This is where we're going. This is the new step, the next step toward trig. is we're going to away from opposite and hypotenuse. Adjacent and hypotenuse, opposite over adjacent. We're going to go to y over r, x over r, y over x. Because that is true for any angle, regardless of if it's in a triangle. That's the thing that when we went through, cosine, you're like, how do you get a negative out of this? How do we have a triangle that has 170 degrees in it? And the answer is you can't. But we can still find those trig ratios, and it's because of this. Okay? What's really important here is that we can shift, and then, of course, other three trig ratios, which are all the same, except, we just flip them, right? But in terms of how they line up, it's the same. This is something you need to start thinking about and memorizing, okay? And the other thing that I want you to know is that our Pythagorean theorem still works for this. Look, I've given you a triangle that has no measurements on it. It has no numbers in it. It is a generalized idea that will work for any triangle. For any point x, y, we can find r. Well, and the way that we do that is by Pythagorean theorem. Okay? The Pythagorean theorem here, x squared plus y squared equals r squared, which means, what is r? How do I solve for r?
X squared plus y squared.
The square root of it. X squared plus y squared. So what's going to happen in your homework today, you're going to be given a point. They're going to actually tell you, point blah, blah, blah is on the terminal side. Find all the trig ratios. And at first, you're going to want to draw stuff. But the reality is you don't need to. If you have x and you have y and you can find r, then you have everything you need because they all fit right into this. Okay? That's the great idea here. The shift that I'm asking you to start thinking about, and it's not going to happen so much in here. This is the very beginning of it. But I will tell you at every higher level math class that you take, from this point forward, the expectation is that sine corresponds to y, cosine corresponds to x, and the tangent corresponds to y over x. And actually, the way that I think about tangent is I think about slope. The slope formula are the difference in the y's over the difference in the x's. And you're going to learn soon about tangent lines. And tangent lines have to do with slope. And so that's going to come into play again later on. This is your brief introduction to it in this course. And as you moved into in pre-calc and to calculus, those are the kinds of things you're going to start seeing and expected to know. And so hopefully this is just a good little introduction to it. Now, let me give you an example. So here's the things that you need to know before we move on to that. Make sure you know these. Okay? Make sure you know these. Make sure you know how to find r. Because everything else is really not too bad. We know how to flip cosecant, secant, and cotangent. All right? Know that sine goes with y, cosine goes with x. Yeah. Let's look at an example. This is the kind of problem that you're going to have to do in your homework. Okay? And this is the thing that I'm going to teach differently than that's in the video. Or was in the old video. Okay? Normally when I do this problem, I start off and I draw it. I draw this point, -3, -4, and I show you where the radius is, and we go from there. And we think about trig in the old way, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. But I'm not going to do that for this. At the very end, I'll show you. Because there's going to be a bunch of problems today where you can't even draw a triangle. So don't try. All right? So I'll let you get that in your notes, and then we'll work through it. I think the way that I'm going to show you first, you're going to find easier anyway. It's going to be less involved, less work to do. Now, here's the great thing about this problem. I've been given x, and I've been given y. The only thing that I'm missing is what? R. I'm missing r. Okay, well, I showed you how to find r. Okay, r is just the square root And now here's where you guys get in trouble, so be careful. Make sure you put the -3 in parentheses. And make sure you put the -4 in parentheses, because we don't want to screw that up. And then go ahead and figure out what that needs to be and write it down, please. All right. -3 squared is what? -4 squared is what? Add them together, what do you get? Square root of 25 is 5. The radius will always be positive. Okay, the radius will always be positive because we're taking the square root of a number. You will never get an imaginary number out of there, but those of you who are like, but my calculator said it's imaginary, it's because you didn't use the parentheses. You can't square a number and it becomes negative. You can't. You square a number, it's always positive unless it's already imaginary, okay? Now, I have everything I need. I don't need anything else, okay? So when I go through and do this now, okay, I can say sine of theta. Well, is sine y or x? Y. Okay, so this is -4, because that's y, over 5.
Why would it be negative?
Because y is negative. It's straight up y over r. Y is negative. Okay? Okay? Cosine of theta, what's that going to be? -3 over 5. Tangent of theta, what's that going to be? -4 over -3, but what happens with the negatives? They cancel, right? And then I just need to find the reciprocals. Easy enough. -5/4, -5/3, and 3/4. Okay? That's the easiest way to do these problems. But it requires you to transition from sine being opposite over hypotenuse to sine being y over r. And transition from cosine being adjacent over hypotenuse to x over r, and tangent from opposite over adjacent to y over x. And so that's something you're going to have to do differently. Now, I'm going to quickly go through what I used to show and what I used to do, and where I used to draw it all out and draw the triangle. And the reason that I've gone away from that is because you're going to get some situations where you can't even draw a triangle if you wanted to. And I know you're thinking to yourself, why not? I'll show you in a second, okay? Now, I'm going to go through this. Do not write this down. Just watch. Just watch, okay? Normally what I would have done without it, I don't. Way is just better. We don't have to worry about it. If you know where y and x and r go, then it's fine. All right, next thing, next subject. Here, maybe I had it first. Oh, is how it would start like this. I go, okay, -3, -4, there's my r. I can make a triangle out of it. We go ahead and find r like we did, because that's all we needed to do. Right? But we knocked this out early. Now, you could still think opposite over hypotenuse, adjacent over hypotenuse, and that works in this situation. Obviously, we still get the same answers. That's not a big deal. Okay? But I'm saving you all this work. There's no reason to do it, because this is what we really need. And if you transition to that y over r, x over r, y over x, then you don't need a picture anyway. Look, let me talk about an example. Reference angles. Totally kind of different. Okay? A reference angle is an acute angle formed with the terminal side of the angle in standard position and the x-axis. X-axis. Always the x-axis. And every year I have kids try to draw a reference angle with the y-axis. Please don't do that. I'm being very explicit. Did you get that? You see what I did there? Thank you very much. What is an acute angle? It is not. No, that's not what an acute is. Smaller than 90 and bigger than 0. That's important. An acute angle is in between 0 and 90. Really important. 0 degrees and 90 degrees. What is it called if it's over 90? Yes. Obtuse. That is correct. Okay. It's got to be acute, smaller than 90. And it has to form with the x-axis. So I'm giving you direction here where to look. Now what you're going to do is it's going to depend on the way the problem is presented to you. Okay? Sometimes the problem is going to be presented to you as in degrees. Sometimes the problem is going to be presented to you in radians. We're going to stay consistent. This theme we've been talking about. If the problem's in degrees, your answer is going to be in degrees. The problem's in radians, the answer is going to be in radians. And that's what this says. Okay? If the angle is given to you in degrees, then the reference angle will be in degrees. If the angle is given to you in radians, the reference angle will be in radians. It starts off kind of the same as what we've been doing. So the first part says sketch the angle and then find its reference angle. Well, you don't know how to do that yet, really. Okay, so go ahead and do sketch 210 like you've been doing. That's the first part here. And that's the way your homework's going to be. That's the way your test is going to be. You're going to have to sketch the original angle, and then we're going to come up with the reference angle after that. So your 210 degree angle should look something like that. Hopefully you got it close. Obviously, that's very nice.
Do you want us to draw something like the blue?
No, you don't have to. That's fine. All right. Now, that part is the same. Okay? Now let's talk about the reference angle. Okay? Remember, it's the terminal side. So here's the terminal side. And the x-axis. So we have two options. It's either going to be here, so this angle here, or here, this angle here. 1 or 2. How do you know? It's acute, which means it has to be smaller than 90. So 1 or 2? 1. It has to be 1. Okay? So this angle right there that I've highlighted in green, that's where the reference angle lies. Okay? And the way that we label that is with this little symbol that says theta with a little, looks like it has an apostrophe on it. This is, shoot. This is known as theta prime, and it always represents the reference angle. Theta prime. Okay? Be careful to always make sure that it goes with the x-axis. Every year I have kids try to make it with the y-axis. That is wrong. Okay? Yes?
Why does it have to be the acute or the acute?
I'm going to get there in a second. It has to be the acute one. Here's why. In a second. Let's just get the
x-axis.
Correct. With the x-axis, the terminal side with the x-axis, and it's got to be less than 90 and bigger than 0. Now, you had to probably figure out what this angle was. You had to kind of, because you're like, all right, I go to 180, and then how much further do I have to go? Well, how much further did you have to go? 30 degrees. So in this case, in our problem, our reference angle is 30 degrees. Okay, now here's why it's important. That gets to your question. Okay? And this is not something we're going to really do much of in this course, but I want you to understand it, okay? The sine of 30 degrees and the sine of 210 degrees, the fraction will be exactly the same, except because the sine over here is negative, because the y is negative, they'll be off by a sign. Same with the cosine. The cosine of 30 and the cosine of 210 will be the same, except the sine will be off. The tangent of 210 and the tangent of 30 will be the same, because tangent is negative over negative, which is positive. So why we use only acute angles is because what we focus on is learning all the different trig ratios for the first quadrant angles, and then we apply them to all these other angles around the unit circle is what this thing is called. And we just have to know what the sign, if there's a sign change or not. And you have to think about, well, is y negative over here or positive over here? Or is x negative over here or is x positive over here? And if they're positive, then those trig ratios are exactly the same. If they're negative, they're the same except they're opposite sign. Okay, and that's something for pre-calc. We're not doing that in here, but just I want to show that to you and explain to you why reference angles are so important. That the trig ratios for 210 and the trig ratios for 30 are basically the same with usual sign exceptions. Okay, now in this next problem, we use radians. Okay, and so I don't expect you to know how to work with radians yet. I expect that what you will want to do first is convert to degrees, and that is completely fine. With one exception, your angle that you draw cannot have degrees on it. Your reference angle will not have degrees on it. It will always have to be converted back to radians. So if the problem is in radians, the answer needs to be in radians. Doesn't mean the work can't be in degrees. And so that's what we're going to do. All right, so if I'm going to convert this to degrees, what do I have to do? Right, I have to multiply by 180 over pi. All right, so my pi's cancel. How many times does 4 go into 180? How many? 45. Very good. Did you do that already, or did you just figure that out? Oh, you did one of those ones. All right, got it. Good memory. All right, so then this, when I multiply it out, is negative 225 degrees. Okay. So when we go to graph this, and we draw, and we go to sketch the angle, all right, I'm going clockwise now. This gets me to negative 180. How much further do I have to go past 180? 45. So when I go to draw this, all right, I do my little curve, and I go about halfway around. No, that's not good. Nope. Trying to go.
Wide?
No. All right, so there's my angle, okay? Except now I need to label it. And don't you dare label it negative 225. This problem is not in degrees. So when you go to label it, you have to label it in radians because this problem is in radians. But we worked through it in degrees. That's okay. I don't expect you to know how to do the radian stuff yet. Next year or a couple of years, you're going to have to know how to do that, but not yet. Okay, now we got to find the reference angle. Well, we found the reference angle. We talked through it, right? We said, all right, we got to go to negative 180, and then we had to go how much further? 45. Well, I can't write 45 degrees on here. Sorry. No dice. This is my theta prime, my reference angle right there. So I need to convert 45 now to radians. Okay, well, we figured out that just up here, right? 4 went into 180 45 times. So guess how many times 45 goes into 180? 4. Okay, so my reference angle is pi over 4 radians. Now remember, since it has to be between 0 and 90, in radians, that means it has to be between 0 and pi over 2. Okay, that's what 90 degrees is in radians. That's just so you know where that has to be. Because normally we think of it between 0 and 90. Well, this is 0 and 90. So pi over 4 is in between 0 and pi over 2. So we're good that we're acute there.
So what if it's not?
Well, then you did something wrong. So I need 2 things for this. Oh, and I need to put I need to make one change. Sorry. Theta prime, theta prime. is pi over 4. Okay?
So, Mr. Zuka,
Yep.
how did you get pi over 4?
Up here, right here. We took 45 and we multiplied by pi over 180. So I'm okay with this work. Don't get me wrong. This work is fine. But what I don't want to see is degrees over here or degrees over here.
How do you get 45?
Because we took 45 degrees, because this was negative 225, we went negative 180. And then we had to go another 45, because 45 plus 180 is 225. Yes. Did we go another negative 45 over here? Yes. But the reference angle has to be between 0 and 90. But in radians, that means it has to be between 0 and pi over 2. Okay? Because the reference angle always has to be positive. And so, in terms of that whole idea of comparing to other trig values, we're just thinking about the positive value. Yes, this is negative 45 degrees, but it has to be between 0 and 90. And in radians, that means it has to be between 0 and pi over 2, because pi over 2 is 90. Okay? So this value can't be negative. The reference angle can't be negative. It has to be between 0 and 90 if it's in degrees, or it has to be between 0 and pi over 2 if it's in radians. Okay, that's the key, right? The terminal side in the x-axis, if I take the short angle, wherever the terminal side is, it's always going to be less than 90. Right? Because the terminal side is in that little quadrant. The only way it could be equal to 90 is if you went all the way here. But it's going to be like here, or here, or here, or here.